Welcome back, everybody. This will be the last video for this part on the calculus review. Let's finish up this test. All right, shade in the region under the curve of the function y equals negative 5x plus 10 with a domain of from 0 to 2 and a range from 0 to 10. Now find the volume of the solid generated by revolving the shaded region about the x-axis. All right, so we have the shaded region. Whenever we rotate this curve about the x-axis, what would we form? Well, if we rotated it over the x-axis, here's our x-axis, here's our line y equals negative 5x plus 10. If we rotated it over, we would have this reflection about the x-axis, and we would form this cone. So the question is asking us to find the volume for this cone. So how can we do this using calculus? Well, if you remember, finding the integral of a function lets us know the area underneath the curve. So finding the integral of negative 5x plus 10 from 0 to 2 would tell us this area. All right, so whenever we revolve it around and make this cone, well, let's think for a second, what is this cone? Well, a cone is just a bunch of circles stacked on top of each other, getting smaller and smaller in respect to this slant. So we would have a circle here, another circle, etc., 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 all the way down. So just like how you use rectangles to find, and Riemann sums to estimate the area and then eventually integrate to find the true area, we can do the same thing with this volume. The only difference is we're adding these areas of the circle. So we need to know, we know that area of a circle is pi times radius squared, but what is our radius? Well, the radius of all of these circles is just the distance from our x-axis to the top, and so our radius is going to be our function negative 5x plus 10, and it will slowly depend on our x value, but our radius is our function y equals negative 5x plus 10. So now we can integrate and use our function as our radius and solve and find the volume of this cone generated from our function revolving about the x-axis. So let's change colors. Let's go to this pink color. So what are we doing? We're integrating. We're using an integral. And what is our distance? Well, our distance is from 0 to 2, the same as our domain. So from 0 to 2 of pi times our radius, which is our function, negative 5x plus 10, all squared dx. All right, so let's scroll down, get some more room for this. So let's move it over here, or right here is good, in the center. All right, so let's solve this integral. So we can pull pi on the outside, as pi is just a constant, and so we have pi times the integral from 0 to 2 of our function squared. So let's go ahead and FOIL this. Negative 5x times negative 5x would be positive 25x squared. Negative 5x times 10 twice is going to be minus 100x. And then 10 times 10 is going to be plus 100. Okay, now we can find the integral for all of these terms respectively. So we still have pi on our outside, and then what do we have? We have the integral of 25x squared. Well, that's just going to be 25x divided by 3. We have the integral of minus 100x. Well, this will be minus 100x squared over 2. And we have the integral of plus 100, which will just be plus 100x. Again, this is all bound from 0 to 2. So let's plug in these values and finish solving for our integral. All right, let's get a little bit more room here. Move this up. So if we plug in 0, we're going to have pi times 0 minus 0 plus 0. All right, so we know that this just equals 0. And whenever we plug in 2, what do we get? Well, we're going to have pi times 25 times 2 cubed over 3. 2, 25 times 2 cubed is 8 over 3 minus 100 times 2 squared, which is 4 divided by 2, plus 100 times 2. Well, you can see here that this 4 and 2 will cancel, and leaving just a 2. And now this term matches this term. One's being subtracted and one's being added. So these can just be canceled, marked out. And so we are left with 25 times 8 over 3 times our pi, which equals what? It equals 200 times pi over 3. So this is the volume for our cone. Excellent. Let's go on to our next problem. Number 17. A rectangular field is to be enclosed on 4 sides with a fence. Fencing costs $4 per foot for 2 opposite sides and $7 per foot for the other 2 sides. Find the dimensions of the field of area 740 square feet that would be the cheapest to enclosed. All right, so here's the area we want to enclose. This side's we'll say this side is X feet, so this side is X feet. This side is Y feet, and this side will also be Y feet. Now, we'll also say that our longer sides are $4 a side. Ones, just because we want our longer sides to be cheaper, and so our shorter links will be the $7 per foot sides. Okay, what else do we know from our problem? Well, we know that the area, so we know x times y equals 740, and what's the question? What would it be the cheapest to enclosed? So we need to figure out a cost. So let's make a cost function. We could say our cost function, c of x. Well, what does this equal? We have 2 sides that cost $4, so 2 times $4 per foot, so for our x, plus we have 2 sides that cost $7 per foot and with a length of y. So let's simplify this a bit. So this is 8x plus 14y. Now we want our cost function in terms of x. So the other thing we have is our area. X times y equals 740. So we can solve for y by dividing both sides by x and have y equals 740 over x, and we can plug this in to our cost function. So let's plug this into our cost function. We'll have 8x plus 14 times 740 over x. Simplifying, we'll have 8x plus 10,360 over x. Feel free to check my math, but I believe that's correct. So now we have a simplified cost function, as simple as we can get it right now. But what do we want? We want to find how it would be the cheapest way to enclose this. So the best way to find this is to find the derivative of our cost function, set it equal to 0, and then we can find a minimum value for our x, and then after we find our x, we can find our y, so we can know how much is $4 and how much footage will be $7. So let's scroll this up some. So again, now we're going to be finding the derivative. So the derivative of our cost function is what? Well, the derivative of 8x is simply 8, and the derivative of 10,360 over x is negative, so let's back up some, negative 10,360 over x squared. Now let's set this equal to 0. So let's set this equal to 0. We have 8 minus 10,360 over x squared. We can move our negative term over and we will get 8 equals 10,360 divided by x squared. We can multiply by x squared on both sides and then divide by 8 on both sides, and whenever we do that, we're going to get x squared equals 1,1295. Again, feel free to check my math. So now we need to find the square root of 1,295 to find the value for x. So luckily, I was really bored one day and memorized my squares up to 50. So I know that 36 squared equals, I know that there's definitely ways to figure this out on your own, but let's just not waste time doing that. I know that 36 squared equals 1,296. And so this is awfully close to this. So we can let's go ahead and say that x is equivalent to 36. Okay? And so what is our y? Well, we know that our area was 740. So to find our y value, let's just do 740 divided by 36. So we'll get 2, 2, 0, add a decimal and a 0, and 6. And let's just stop there. So we have our x is equivalent to 36, and our y is equivalent to 20.6. Therefore, what does this tell us? Well, this tells us what? It tells us that actually, let's go back to the very top. It tells us that this length is 36 and this length is 20.6. So what would be the cheapest way to enclose? Well, to enclose the whole thing is the perimeter. So we have 36 plus 36, or 36 times 2, which is 72. So we have 72 feet that will cost $4. So this will be 72 feet for 4. And we have our 20.6 and our 20.6. So 20.6 times 2 equals what? Well, that's going to be 41.2 for $7. And so what is our final answer? Well, I think we can leave our final answer as that. So 74 feet at, or I'm sorry, it was 72 feet. 72 feet at $4 per foot. And 41.2 feet at $7 per foot. Excellent. Let's go to our next problem. Use a finite approximation to estimate the area under the graph of the given function on the stated interval. The function is f of x equals x squared, and the interval is from x is 0 and x equals 3. Use the left sum with two rectangles of equal width. So we want to find the area under the curve from 0 to 1, 2, 3 to 3. However, we're not just going to integrate. This wants us to use a left sum. So a left sum is taking the point, and it says two equal rectangles. So what halfway between 0 and 3 is here, which is 1.5. So a left sum starts at where the point hits the function. This is our function x squared. So it hits at 0, and then it goes all the way over to 1.5, and you add everything beneath. So for this first rectangle, the area under the curve is 0, as it has no height. So for our second rectangle, starts on the left side because it asks us to do a left side sum. So we go up to here as it hits our function at this point. We'll go over to 3. We will form this rectangle, and so whatever this area is will be our left sum with two rectangles of equal width from 0 to 3. So what is the area of this rectangle? Well, what is the length? Well, 1.5 to 3 gives us a length. So area of a rectangle is just what? Length times width. So it gives us a length of 1.5 times our width, or our height rather. So what is this height? Well, this height is an x squared function, so 1.5 squared is 2.25. So our width, or our height, is 2.25. and 1.5 times 2.25, well, half of 2.25 is 1.25, and so that added to 2.25 gives us 3.375. So this is our area. And so this is our answer for our left sum. Excellent. That problem was easier than the last couple problems. Let's go on to 19. Find the area enclosed by the given curves x cubed and 4x. So this green line, this is our f of x, or I mean our blue line is our f of x, and this dark red is our g of x. So how do we find the area between the two curves? So we want to find this area and this area. So how do we do that? Well, we know for our g of x, if we were to find the integral of our g of x, we find everything under our g of x to the x-axis. So we would find this whole thing if we were to integrate our g of x. And we also know that if we were to integrate our f of x, we would get everything from underneath the curve to our x-axis again, so it would be this part. Or overlapping colors, it would be this part. So what we can do to find the area between the curve, we can take our integral of g of x and subtract our integral of f of x. And this will give us the area between our curves. Okay, so the last thing we need to figure out is we need to figure out the bounds for our integral. Okay, our function crosses at this point, at the origin, and at this point. So what are these values? We need to know what to find our bound. And how can we find these values? Well, they cross whenever our functions equal one another. So when does x cubed equal 4 times x? Well, the obvious case is the origin, 0, 0. So let's exclude that. Let's figure out this point and this point. Well, look at this. X cubed equals 4x. Well, 4 is a perfect square. 4 is just 2 times 2. So we have something x times x times x. We have 3 x's times 2 times another x. So x is obviously going to be 2. And then x can also be negative 2. So this x value is negative 2, and this x value is positive 2. So our integral can either be from negative 2 to positive 2 to get all those. But let's actually, these are just mirrors of each other. This first quadrant and this third quadrant, first quadrant and third quadrant, they're just mirrors of one another. So what we can actually do is we can take this integral to find the area between the curve, and we're going to do it from 0 to 2, and then we're just going to multiply it by 2. So we're going to find the integral from 0 to 2, and then multiply our answer by 2 so we can get both of these areas. All right. So let's do that. Let's get to work. Let's get some more room here. All right, this is good. So again, let's rewrite what we're doing. We're finding We're multiplying by 2 of our integral from 0 to 2 of our g of x, which was 4x. And then we're going to be subtracting the integral from 0 to 2 of our f of x, which was x cubed. So what is the integral? And of course, what is the integral of our 4x? Well, the integral of 4x is 4x squared over 2. And then we will be subtracting the integral of our x cubed. The integral of our x cubed is what? Well, it will be x to the 4th over 4. And again, these are bound from 0 to 2. And we won't forget to multiply in our 2. All right. Let's get some more room. Put it in the center a little bit. So when we plug in 0, what do we get? So let's plug in 0 first. We'll get 2 times 0 minus 0. So this equals 0. Not exciting. And now what happens when we plug in 2? So we'll have 2 times 4 over 2 squared. 4 over 2 squared, so 4 times 4 over 2 minus 2 to the 4th over 4. What does this equal? Well, a 2 and a 4 can cancel a little bit. So 4 times 2 is 8. And then 8 minus 2 times, or 2 to the 4th is 2 times 2 times 2 times 2, which is 16, divided by 4 is 4. So 8 minus 4 all times 2, which is 8. So the area between the curves is 8. Excellent work. Let's go to our next problem. Evaluate the integral using substitution. All right. So using substitution, we use u substitution. Let's say our u equals 4x minus 3. And so our du over dx, here I don't want my face cam to accidentally get in the way, so let's say our du over dx equals what? Well, what's the derivative of 4x minus 3? It's simply 4. And yeah, so what does this mean? This means that our du equals 4 times dx. And so now that we have our u, let's plug it into our integral. So what was our integral? Well, in the beginning it's 12. I'm going to rewrite 12 as 3 times 4. And then we have what our u is going to be, our 4x minus 3 to the negative 5th dx. So what do we have? We have our u is our 4x minus 3. So our u is our 4x minus 3. And then our du is a 4 times a dx. So we have a 4 and we have our dx. So what are we left with? We're left with 3 times u to the negative 5 du. Now we can solve this integral. Whenever we integrate this, what are we going to get? We're going to get negative 3 u to the minus 4 all over 4. Now we can plug back in our value for u. Plug back in our value for u, and we will get minus 3 times 4x minus 3 all over 4. And don't forget to add our plus c, because it can be plus any constant, as this integral is not bounded. So this is how we can use u substitution to find this integral. Awesome. Let's go on to our very last problem. Consider the trapezoid bounded by the line y equals 5 minus 3t and the x-axis from -2 to x. The area function is given by the integral from -2 to x of f of t dt gives the area of the trapezoid for x is greater than or equal to -2. Okay, so part A is evaluate a equals -2. So a of -2, well, that's just plugging in -2 for our x. And an integral from -2 to -2, well, that's just going from here to here. So no matter where you go, there's not going to be an area under any curve. So this is just 0. Okay, now evaluate a of 0. Okay, so here we can actually do some math. We'll have the integral from -2 to 0 of f of t. Well, what is f of t? It's 5 minus 3t dt. And so let's find this integral. So the integral of 5 is going to be 5t, and the integral of minus 3t is going to be minus 3t squared over 2. And this is again bound from -2 to 0. So we can plug in our -2. We'll get 5 times -2, which is -10, minus 3 times t squared. -2 squared is 4. So this is going to be minus 3 times 4, which is 12, over 2. 12 divided by 2 is 6. So -10 minus 6 equals -16. And then if we plug in 0, we'll have 0 minus 0, which is 0. And then if we subtract 0 minus 16 to find the area, we will get 16. Also, areas are always positive, so if you get a -16, you're going to know you're going to have to use the absolute value to put it as a positive 16. So evaluate a of 0, that this value is 16. Lastly, let's clear this up to do part C. Part C says what? It says compute the derivative of a with respect to x. So find the derivative of a with respect to x. All right, so what can we do for that? Well, what is a? A is this function given, so the derivative of a with respect to x is going to be what? Well, the derivative is going to be, we'll have our d over dx times this integral of -2 to x, f of t dt. But all of these, this is going to cancel, and this is going to cancel, and you're just going to be left with our function. But our function is in respect to x. So what's left is just f of x. And what is f of x? Well, it's our original function in respect to x rather than t. So our answer is just going to be 5 minus 3x. And this is the answer to part C. All right, guys, that wraps up the final part of this calculus review. I hope you learned a lot. If you need any further explanation, let me know in the comments down below. I hope I helped you out, and I hope I can continue helping you. Take it easy. Take care.